The laws of physics are not what you think they are. We like to think we have a pretty good handle on the laws of physics. They're our guide to the universe. The rules that explain everything from an apple falling off a branch to the grand dance of galaxies. But what if those laws aren't just wrong, but wildly incomplete? What if I told you that scientists just found something so profound it might shatter our most basic ideas about how reality works? They've discovered particles that just don't play by the rules. Particles that behave in ways we thought were impossible, that seem to bend the very fabric of existence. Is this the start of a new chapter for humanity, one that will force us to rewrite all the textbooks? Or is it a chilling sign that we know far, far less about the cosmos than we ever dared to imagine? What if reality itself is not what it seems? A crack in the mirror of reality, the first clues that something was off, didn't come from a giant, billion-dollar particle collider. They came from the bizarre, flat world of two-dimensional materials. Imagine trapping electrons in a sheet of material so thin, it's basically a quantum prison, just one atom thick. Normally, when you apply a magnetic field to a conductor, you get a small voltage on the sides. In the quantum world, that voltage doesn't climb smoothly. It jumps up in perfectly even steps. These aren't true fundamental particles, but emergent behaviors of the whole system that act like particles. And these theoretical quasiparticles had wild properties. They could have fractional charge, and they wouldn't be fermions or they were nicknamed anyons, because they could have any kind of quantum behavior in between the two main families. But in the fractional version of this effect, scientists saw something that made no sense. The steps were in fractions. It was as if the electrons, our supposedly indivisible particles, were somehow teaming up and acting like they only had a fraction of their charge. The big question remained. Could you ever find, isolate, and prove that a real particle with this rule-breaking behavior exists? Could you build one? And even more importantly, could you control it? You can poke and prod charged particles with electric fields, but a neutral particle is like a ghost. It doesn't listen to your tools. Until recently, actually seeing and manipulating a neutral particle from this fractional world was considered a theoretical fantasy, waiting for an experimental miracle. When you take this setup, cool it down to temperatures just a sliver above absolute zero, and then hit it with a magnetic field millions of times stronger than Earth's, reality begins to fray at the edges. This bizarre setup creates a phenomenon called the fractional quantum Hall effect. This was a major crack in the facade of physics. It led theorists to dream up the idea of quasi. For a long time though, this was mostly math. It was cool, but there were effects, not things you could touch. The challenge seemed impossible, especially if the particle you were looking for was electrically neutral. Okay, let's pause for a second. We're about to get into what this really means for the future, and this is where science starts to sound a lot like science fiction. If you're finding this trip into the quantum world as mind-bending as I am, take a moment to hit that subscribe button and ring the bell. You are not going to want to miss what comes next. Rewriting the textbooks. So, what does this actually change? Well, for starters, the textbooks, the neat and tidy boxes we had, labeled fermions and bosons, just aren't big enough anymore. Physics textbooks, from the most basic to the most advanced, will literally have to be. It doesn't explain things like dark matter or dark energy. While these new particles don't solve those mysteries directly, they prove that our current rulebook is missing pages. They show that matter can assemble itself in complex ways we never even imagined. We now have experimental proof that a third category exists, and maybe more. Particles can live in the strange borderlands between the two families, following rules we're just now starting to figure out. This forces physicists to rethink their most fundamental theories. The Standard Model, for all its success, has huge gaps. It's now been seriously challenged. While a single, free electron will always have a charge of -1, this research proves that inside a quantum system, that charge can be effectively split up and shared among other particles. It reveals a deeper, more complicated layer to what we thought was a simple fact of nature. This isn't just a new fact to memorize. It's a fundamental shift in how we see the universe. It tells us that the cosmos is far more creative and complex at the quantum level than our old rules ever allowed. Think about it like this. For centuries, mapmakers knew about land and sea. Then one day an explorer comes back with news of something else, a world of floating islands that are solid land or liquid sea. But something totally new. That's what just happened. Physicists have found a new way for quantum matter to exist. And that idea that charge is perfectly indivisible. The dawn of a new technological era, as mind-blowing as this is for physics, the practical side could be even more world-changing, especially for the future of computing. The biggest roadblock for the quantum computing revolution is a problem called quantum decoherence. The building blocks of quantum computers, called qubits, are incredibly fragile. The tiniest vibration or change in temperature can make them lose their quantum state, destroying the entire calculation. Because they're electrically neutral and have a unique, stable quantum structure, they are thought to be much more resistant to all that environmental noise. They're just naturally tougher. And remember, the scientists at Brown didn't just find these particles. They showed they can control them. That turns them from a scientific curiosity into a potential building block for new technology. Using these new particles to store and process quantum information could be the key to building fault-tolerant quantum computers, machines stable enough to finally solve problems that are impossible for today's best supercomputers. It's like trying to build a complex sandcastle during a hurricane. This new understanding could lead to things like hypersensitive quantum sensors, or new kinds of materials with properties we can't even dream of yet. As Jia Li said, we've essentially unlocked a new dimension for exploring and manipulating this phenomenon, and we're only beginning to scratch the surface. We have a new piece on the cosmic chessboard, and we're just now learning how it moves. This is where fractional excitance could be again. It's a possible path toward quantum computers that are not just powerful, but actually practical and robust. The research team believes these particles offer totally new ways to handle quantum information, potentially leading to much faster and more reliable quantum machines. Imagine swapping those delicate grains of sand for interlocking bricks that can withstand the storm. That's the promise here, but it might not stop there. So, where does that leave us? We started this journey with the solid, reliable laws of physics. We saw how a strange glitch in a two-dimensional world hinted at a deep crack in those foundations, and now, we're staring at a genuine breakthrough. The discovery of fractional a new class of particle that breaks the old rules and lives by its own. This isn't just another entry in the particle zoo. It's a paradigm shift. It challenges our most basic definitions of matter and shows us a quantum world far more complex than we ever knew. The discovery of the fractional exciton isn't the end of a story. It's an invitation to explore a new reality that was hiding right under our noses, just waiting for us to build the tools to finally see it. The question is no longer if our model of reality will be broken, but what we will build from its magnificent, shattered pieces. The neat little boxes we made were just a convenience for us, not a fundamental law of the universe. This discovery doesn't just promise to rewrite textbook, it could hand us the key to one of the most transformative technologies ever. Stable, large-scale, quantum computing. From pure, abstract theory to world-changing tech, the story of this strange new particle is just getting started. The universe has once again reminded us that it is far stranger, more intricate, and more wonderful than we ever imagined. What do you think is the most exciting part of this? Discover the new physics or the new technology? Let me know your thoughts down in the comments. And if you want to stay on the cutting edge of science that sounds like science fiction, make sure you're subscribed with notifications turned on. Thanks for watching.